Hey everyone, welcome back to another video. Today we're going to be going over vector versus scalar quantities, the distance between distance and displacement, and we're going to be doing a little introduction on vector graphs. So in future videos, we're going to be going more in depth into these vector graphs using trigonometry, such as sine, cosine, and tangent. Okay. So now I want you to look at the two problems I have on the screen. So this is going to be a warm-up for today. So in the first question, we have 3 meters, right, and 6 meters. I want you to find the distance between the two boats in meters. So we have meters equals blank. And then for question number 2, I want you to find how you would get from point A to point B. Okay, so let's just say the distance is 10 meters. Okay. If I was trying to get from point A to point B, you have to be specific. How would you describe that? Like, you wouldn't just say you walk 10 meters. Right? You have to be specific. Like, do you walk 10 meters forward? Do you walk 10 meters backwards? Be specific. Okay. So for question number 1, it's very simple. We'll just have to add 3 meters plus 6 meters, which equals to 9 meters. Okay. 9 meters is your answer. So this right here is called a scalar quantity. What a scalar quantity is, it's really just magnitude. So as a short reminder for magnitude, magnitude shows how large or small a value is. So for instance, magnitude would be like 9 meters, right? That's literally this, okay? Another value would be like 10 kilograms. Okay? These are examples of scalar quantities. Okay? So for number 2, how would you get from point A to point B? Now we're going from the left to the right, right? So basically, we're moving to the east. So it would be 10 meters to the east. Okay. Now this is called a vector. A vector is really just magnitude plus a direction. So an example of example of a vector would be 30 meters to the north. Okay, that's the example of a vector. Another example would be velocity, right? Velocity. Well, many people messes up, okay? So a lot of people think that velocity and speed are the same. Well, they're not, okay? So velocity is a vector, whereas speed is a scalar quantity. Yeah. Okay, so velocity, for example, if I were to say there was a car, right? It was moving this way, okay? So it's moving east. So for that, the speed would be, let's just say like 20 miles per hour, right? 20 miles per hour. However, the velocity would be 20 meters per hour east. Okay? Between distance and displacement. So from the example from before, we had 2 boats and they were separated by 9 meters apart. Okay? So we know that 9 meters is scalar because 9 meters only shows magnitude. So therefore, distance would be scalar. Okay? So if I were to say that I walked forward 3 meters, so that'll be 3 meters north, and I walked backwards 4 meters, so 4 meters south, what do you think my displacement would be? Well, first of all, we would like to set 3 meters north as positive and 4 meters south as negative since they're opposites. Okay, I just like setting north as positive because on a graph, this value would be positive and then this side would be negative, so it's easier to remember. Well, the displacement, it would be 3 meters, right? And then you would subtract 4 meters. So Therefore, it would be negative 1 meters. And the negative sign represents that it's going south, so it will be 1 meter south. Okay, and since this value, it has a magnitude and a direction, displacement is a vector. Okay, but if I were to ask you what the distance walked was, what would you say? Well, distance, it represents the amount. Well, in this case, it represents how much you walked in total. So it would be 3 meters plus 4 meters, and it would be 7 meters. So the distance would be 7 meters. And so now we're going to move on to graphing. To understand graphing, we're going to have to understand direction. So first we have north, west, south, and east, right? So if I were to give you an angle, right? So there's an arrow going and there's 45 degrees. How would you tell me which way this arrow is going using this angle? Okay. Well, most of you would probably say like northeast, right? Well, it's not really right. So I'm gonna tell you why. So first we write 45 degrees, right? And we have to say which directions it's going. So we know that it's going north and east, but it could be east of north or north of east. So we have to figure out which one it is. Well, we know that this angle right here, right? It's touching this northern side. So let me show you a little trick. Well, we know that it's going north and east. So since it's touching north, we would write north at the end. Okay, so it would be 45 degrees east of north. Okay. Well, if I were to give you a different example, like this, for example, 30 degrees, and it's going south and east, right? So what would the direction be? Well, we know that this angle part is touching the southern part. So it's 30 degrees south. Then we have a blank here. So it's 30 degrees blank of south. Well, it's pointing south and east. So the only other option besides south would be east. So it's 30 degrees east of south. So now we're gonna actually move on to graphing. So we're gonna have, so let's just say that we wanna have 20 meters, right? 20 meters at 30 degrees north of east. Okay, we have a graph here, north, west, east, south. Okay. Now you may be wondering, how do we use the meters in this case? Well, when we have a graph, we would usually set a scale. So we could have like, let's just say like 10 meters, right? Is equal to 1 centimeter, right? So when we graph this, we would need a ruler and a protractor to graph it, okay? So basically, we would need to graph 2 centimeters at 30 degrees north of east. Now, using the method that I showed you before, we know that it needs to touch the east line. So it would be here, right? Okay. And then we want 30 degrees. And it should be at north and east, right? North of east. Okay. So this would be 2 centimeters. Right? Okay. Now we're gonna try this next one ourselves. Okay. So we have graph. The scale would be, let's say like 20 meters per second is equal to 2 centimeters. Okay. And then I'm going to give you 40 meters per second at 60 degrees south of west. Okay. So how are we going to do this? Well, we're going to look at the last one again. Well, it's west, so we know it's going to be on this western line. We also know it's south, so it's around this area. So we'll just graph it over here, and then we have 60 degrees here. And then when you use your ruler, this should be 4 centimeters because you have um 220 meters per second, and you would just do 2 centimeters times 2, which is 4 centimeters.